So coming up, we have Csongor Vogel, who is a Flutter chapter lead at Talabat from Delivery Hero. Apart from building a full-time Flutter application, he's also a university lecturer at university in Hungary. The list there is one more to add to list. He's also the organizer of Flutter Abu Dhabi and Flutter Dubai. So let's welcome Csongor for the talk.
Hi, Ahmedabad. Kem cho? Machama cho? Jai Shri Krishna, everyone. So, let's get started. Hi, everyone. My name is Csongor Vogel. I'm a Hungarian Flutter developer right now based in Dubai. In details about me, just really quickly, I'm a Flutter software engineer at Talabat from Delivery Hero, which is one of the largest food delivery applications in the Middle East. Besides that, I'm also, as it was mentioned previously, I'm also teaching Flutter in my country in the university. We had like successful six semester so far. And to give back to the community, I'm also a co-organizer for Flutter Abu Dhabi and Dubai. But today, we would like to talk about functional programming. Functional programming is a universal topic, but today, as you saw in the agenda, we will cover the main principles, the basics, and we will see that what kind of language features that Dart provides us to basically achieving functional style implementations. And last but not least, we will also take a look at the useful packages, which can also speed up and boost our productivity in the functional field. So, functional programming. Functional programming is a programming paradigm which is heavily based on the mathematical functions. It has main principles and goals like purity, immutability, high-order functions, and the declarative programming style. But to understand it more, let me invite everybody for a time travel. Let's go back to the school, go to the math class, and let's see that what we learned about mathematical functions. So, mathematical functions, basically, they are representing like a set of rules between two sets, the set of inputs and the set of outputs. So if you are taking an example about one function, which is like returning with the double value of an input set, we can say that basically every input will have only one output. Similarly to this, if you are taking another example of the square operator, with the square operator we will notice the same thing, the same result. Every input will have only one output. There are no exceptions. So what we can say about the cases when one input will generate different outputs with the same functions. In that time, we cannot call this as a mathematical functions. This is what we call, this is the rule of purity. So basically purity specifies that functions always produce the same output for the same input and there are no side effects. Understand it more, let's take another example. Let's check the example of the area of a circle, A equals pi r squared. Let's get a look on the implementation. There are no magic. Basically, we have one single parameter with the radius, and we will return with the multiplication of with the radius and the pi variable. We can have like a small example, like we can have like a set of inputs, and in these inputs we can iterate and we can also print the area results to the console, as you can see in the comments below. But there is only one issue with this implementation. If you take a note on the pi variable on the top side, then you can see in the current implementation, as it's like a var and like a mutable variable, there is a chance that like a scary other isolates or a sleepy colleagues or someone else, my dog, just come and basically like override the value of my pi variable. In that time, for example, 2, 3, and in that time, if we are basically iterating on the same input fields, then we will see different outputs on the console with the same function. So right now, basically we break the rule of pure functions. So how can we solve it? To solve it, mathematicians introduced basically the rule of immutability. Immutability, according to immutability, data cannot be changed once it's created, reducing the chance of unexpected mutations and making the code more predictable. This is exactly what we needed in our example. So going back to the example, let's make the pi variable as immutable. We can do it, for example, using the const keyword. And after that, we ensure that every time when we are using our area of circle functions in the same parameters, we will have the same results. So basically, we will depending only on the parameters of this function. And if we are talking about testing or maintainability, we can make sure that this function, our function, purely will provide the same responses and results, which makes also our application more stable. Let's continue. Let's stay with our example, and let's verify and check that what should we do in our calculation with negative numbers. What will happen if the radius is negative? We can consider one example. We can say that we are modifying the implementation of our area of circle function. We can say that if the radius is negative, then we can just return with an error. We're just throwing an exception. But the issue with that, if we are checking basically the type of our function, that basically no one else is notified about that if they want to reuse this function, that it can also throw an exception. Unfortunately, in the Dart language, we cannot specify a function explicitly that this can be like return or can throw a function which can cause multiple side effects in our application. So what else we can do? For example, we can use the nullability, the null safety, and we can mark our function as can return with a nullable value. So we can return null if the radius is negative. But let's take aside this type of error handling. We will take a look at it later in the second part of the presentation. Let's take another approach to solve the same issue. So we have, as I mentioned, we have like a list of inputs. We have like a for loop. We are iterating in the for loop. We are basically reading a radius value from the input list. Then we are also calculating the area of the circle, and we are printing it to the console. I didn't basically, and if we want to, like for example, like adding our null check, we just need to add it to that place. Why I needed to like step by step like explaining every line in this implementation? It was thanks to the fact that it was implemented in an imperative style. So in imperative style, basically we are specifying how to do something. For example, by step sequentially called operations, what we had in our situation. And as you mentioned, like changing this implementation, adding something to it can be challenging can be challenging sometimes. So let's see what functional programming prefers. Functional programming prefers the declarative style, where basically we are specifying what to do instead of how to do. So in functional programming, you can see that basically with this approach, we can achieve like a more readable implementation. We can easily change the order of these operations. We can skip, for example, the first element in these input fields. We can also iterate on that, and we can again like printing the results to the console if we want. And we can also take, for example, the last two parts, and we will see the results in the console. We can continue basically in the declarative style. We can have like wider ideas to improve our code, or just like doing something fun. We can basically consider that why we are iterating again in our whole collection just to print the results to the console. why not just passing a function to to another function and doing the print logic when we already have the value in our iteration? But can we do that? The good news that high-order functions are supported also in functional programming, and functional programming is heavily supporting the idea of passing a function as an argument or to another function, or basically a function can also return with another function. So how does it look like in our example? So we can say that we have the area of circle function, and and basically we can change it like receiving a function as a parameter, like the second parameter, which will be the print function, and then we can use it locally. So we could reduce basically the code, what it looks like from outside. So let's summarize the principles, what we learned about functional programming. So functional programming, as we saw, heavily based on mathematical functions, and it also represents a contrast to the object-oriented programming, where basically we are doing the opposite. We have objects where basically mutating the inner state of our objects. And the object-oriented programming is heavily relies on the imperative programming style. So the main goals: purity, immutability, high-order functions, and declarative programming style, which are heavily supported and purely supported by the pure functional programming languages like Haskell or F#. But what about the good news that basically the modern languages like Java, Kotlin, and other languages are basically also supporting as a multi-paradigm programming language these type of functional style. But basically in a Flutter conference, let's check what Dart language provides us. Let's continue. Let's see what kind of language features what we can use in Dart. And I promise, guys, I will be super short, and then later on we can enjoy together the chais in the chai break. So please stay with me. Okay, so the first thing, immutability. We can support immutability by using final or the const keywords. So we can basically restrict the reinitializations of our objects. So as you see, the const int age cannot be changed. We can receive like a compile time error if you want to change a const one. What about the collections and the list objects? Now, this is a tricky situation because, again, with the const keyword or the final keyword, we can restrict the reinitialization. But unfortunately, the content of these collections still can be mutable. We can add or we can remove elements from our collections. What about one of my favorite model? We have a chai with a type and the best price. And for example, what about how can we make this class also immutable? Unfortunately, if you are using the final like keyword on the class level, unfortunately, this is not restricting the reinitialization of our object, but we can specify our fields and properties inside of this chai. We can specify the type and the best price fields as final using the final keyword. And for example, if my favorite chai was the masala, I cannot change my mind. For example, to the ginger chai, I should be stay with the masala for a life. But let's see, can it be changed or not? But how can we change my taste with chais? For example, we can use the copy with functions, which is not overriding the existing objects, what were like the objects that were like initialized. We can basically creating a new object by using the copy with function. So, for example, later on from masala, my new favorite chai can be the Rajwadi, what I heard that is really famous in this area. Continuing the list, we can use top-level functions. Basically, like every example previously was also top-level. I didn't need to like implementing like a class or like an object to using functions. In their functions, I could directly creating functions also even outside of my main function. We can also greet each other by using the camcho, and for that we can also use like anonymous lambda functions, where basically we can also assign a function to a variable, how it's look like in this slide. And also, we can use another type of anonymous function, which is like the closures. And in this example, basically, we can play with the inner scope of our my counter closure. And by using it, we can iterate on this inner state. And last but not least, we can have also extensions, which can help us like composing and extending the functionalities of our functions and other objects. So basically, extensions can be also really handy, like chaining our operations. And then basically in this year was a huge milestone for the functional programming community in Dart, because the Dart 3, the version 3, was bringing us like tons of long-awaited features, which are like heavily supporting the functional programming. First of all, we can talk about the records and later the patterns. We are not going really deeply these examples. I heavily recommend you guys to visit and check Pascal Wesch, like extremely useful and insightful session from FlutterCon Berlin, which he gave. But let's take a look on the syntax, so we will understand the examples in the end of this talk. So we can have records. Records, basically, inside of our parentheses, we can bundle objects with types, with named or unnamed parameters. And basically, we can say that we have like one record, which is the best conference in this year. And we can create another object, like the next best conference, which can be the next year ones. And take a look at the right side. Basically, we are not overriding the previous records. We are creating a new instance. So this is also helps and supports the main idea of immutability. So the records are super immutable objects. And last but not least, yes, we can use like unnamed versions of it. And one of the main benefits of using records, that by using records, we can return multiple values. In the past times, before Dart 3, unfortunately, it was not available. But in this case, if you're taking a look at the function of getName, using the getName, we can return with two different values in the same time, which is super handy. And in the other side, we can also handling these values by using destructuring. So destructuring is a part of the pattern matching, and with pattern matching, basically these expressions letting us like matching the middle like behaviors in our expression. So for example, we can also take a look at the exhaustiveness on pattern matching. So we can have an example like how can we describe two Boolean values behavior. Basically, we need to collect all of the cases, which can be what we can consider. And if one of the case is missing, then we can receive like compile time issues. So we can, with pattern matching, we can have like a much more smart like switch operation, what we can use in our functional programming implementations. And we need to also talk about the algebraic data types. So this is when we have like different like family-related types. So in the calculate area operation, we can basically like running a specific operation for each different types. These the algebraic data types helping us basically reducing the cases like we won't be able to force creating objects, which would be like object-oriented. We can stay more in the functional programming world. So we learned a lot of things. Basically, our package is full of learned Dart language features. Now, let's talk about serious, real examples. Let's talk about serious business. Let's get chai together. So, as I mentioned, I will be quick, and then later we can have like a real chais in the chai break. So let's get the chai. We will have a future function which we return with the chai model, get chai. No surprise. Seemingly really easy. But if you are taking a look at the implementation, then we can see that this chai is not the only type what we can receive if we are like calling this getChai function. We can have like server issues, we can have no internet issues, maybe like having a chai is super secure and we need to authenticate our users. So we will need to face like multiple error scenarios, but we just wanted to have like one chai. So how can we solve it? And the main issue with this scenario that we can see that if someone wants to call our getChai function, they also need to cover their implementations with another try-catch block, and we can have these in every layers, and this can also like add multiple unnecessary scenarios for the developers. So how can what we can use, what can Dart provide us to solve these issues? For example, we can use the recently introduced sealed class and final like class modifiers. So we can have like a result object with two children implementation. Like base class, we can have like a success and the failure case. The success case can also like contain our chai object. Then we can have also like a failure where we can store our exception or the error description. So let's take a look at the original implementation. That was when we just had the try-catch implementation with the chai, and basically introducing the result object, we can return with the success and also with the exception case. There are no changes here, but on the user side, finally, instead of just returning with future chai, we can basically prepare our colleagues and other people who are using it to basically like handling this in the proper way, and the pattern matching, what we learned previously, will help us to also like returning the error case. So we could get like one chai, but we can be picky in the upcoming minutes. So I would like to know more about what kind of chais what you guys are preferring. If you could help us, like how we can get, for example, the best chai here in Ahmedabad or in the conference. How can we order the best chai in the conference? Can someone like share some insights, like ideas, what kind of like things what I can consider like ordering chai? If someone has any idea. Which one? Chai point? Chai point. What is the chai point? If someone can explain it. Oh, okay. Okay. From my side, what can be like useful for me to like decide what can be like a good chai. One of the things can be, for example, having a chai like immediately. So, for example, the delivery time can be super important. I'm really relying on your what you guys are preferring. So for me, it's important to know what is the popularity in your side, and also I'm super excited about what kind of offers when I can get if I'm ordering a chai. Can I have like a samosa as a hot deal or a best deal? So all of these things can be important for me. So let's take an example. We learned previously the result object together. So let's implement it, but there will be one issue. If you are using results and wrappers, then this will be the result, and I would never call it as like a readable, maintainable code. By the way, this issue was also rightly pointed out by Andrea Bisotto. So in this article, you can also learn more about this problem. But we will solve it together, but let's take like what kind of packages, what we can use it to support it. So for useful packages, when we are talking about functional programming, darts and fpdart are the mandatory options. But for example, if you just want to focusing on the immutability side, then basically the fast immutable collections, which are like solving the problem what we saw with the can be also handy, or the freeze package can also use like creating the copy with functions with our classes. And last but not least, if someone is suffering in our current code base, like needs to maintain like an enterprise code base, which right now is not easy to like above Dart 3, then they can also use some packages, the tuple or the sealed union, so they can also enjoy these language features. Today, we were just covering up the fpdart package. As you see on the right top corner, this package was recently introduced and added also the Flutter favorites packages. And this is super and well documented, guys. So as you see, there are tons of tutorials can help you to preparing your functional journey. Basically in fpdart and in the Dart side, and it also introduces like multiple types for us, so we can use them to basically achieving this functional implementation style. We will talk about mainly the either function. So the either function, basically we can replace our result objects later on. Basically it has, the either has like two sides, the right side for success cases and the left side with the left cases. And as you see, we have like tons of like extensions and operations what we can use to also like combining these types. So if you want to use the either from fpdart, and if you guys are remembering the getChai example, then instead of using the result object with failure and success case, we can migrate it to the either class and types, and we can just handle according to the like success and error cases. And from the caller side, like there won't be like a huge surprise. We can also use the pattern matching from fpdart. So inside of our switch case, or instead of our switch operation, we can also have the pattern matching implementation from fpdart. But we can also use task types. So in functional programming, we can easily like combine different functional programming types. We can have task, which is basically like a wrapper about the future. So basically, if you see that the future, like we have like a bit ugly syntax, like we have like future inside of it, like either inside of it multiple types, just to like having a child. So we can also use the task basically like to like changing and make it more readable. So we can use the task and either functions together with the task either type, and basically by using its try-catch operation and constructor, we can have like a much more cleaner way. We can also use the pattern matching in our task either implementation. And why we needed to basically like learn all of these features, or like why it was like useful basically to like experimenting the usage of fpdart. Basically, if you guys are remembering what kind of how did I wanted to like selecting the best child for myself with the different aspects with our complex example, then by using basically the task either instead of this ugly implementation, we can have like a much cleaner and readable way. So basically, in the end, hopefully, everyone can also find the best child for himself. So let's talk about the conclusion. The conclusion and my main key takeaways that, first of all, understand the key concept of functional programming. So following the immutability, following the pure functions concept can like heavily make our life and basically our implementations more productive and more maintainable. Like we can use them when we are creating unit tests. We will see that like handling pure functions, how beneficial can be in our daily job. And also be aware about the Dart features, because in the recent times we received multiple language features. So the Dart team is working on making our life easier. And you can be like functional like tomorrow, but you don't need to be 100%. So please start small. If you want to like just immediately changing and introducing functional programming in your code base, please discuss it with your colleagues, because all of you need to adopt these concepts together, and the learning curve can be a bit like longer than what we used to in object-oriented programming. I created, I collected some resources. You guys, as I mentioned, there are tons of resources available and tutorials, and there is also like a playground project, what you can also take a look. And guys, as I promised, let's have a chai, and after that, during a chai, we can also discuss if you have like any questions. Thank you so much, everyone. Do we have time for questions, or should we have the questions during our chai? Let's vote. Then if not, then guys, like let's meet and let's catch up on the other side, and let's consume the chai together. Thank you so much, Andabad. Thank you.